Hi everyone, I'm Tim Smith. I'm the Director of Data Center Business in Huawei in the UK. Today I'd like to run through some slides and introduce the application of lithium batteries in data centers. In this presentation, you will learn about how lithium-ion batteries benefit data center operators and how to increase lithium-ion battery reliability. Through this study, you will have a deeper understanding of lithium battery applications in data centers and learn how to enhance the security design of lithium battery systems. First, let's talk about what the benefits are for using lithium batteries for data centers. From the launch of the first commercial lithium-ion battery in 1991, the large-scale use of lithium batteries in telecom base stations in 2009, to the explosion of the electric vehicle market in 2016, the combined battery sale of the top 10 lithium battery manufacturers in the world is nearly a massive 90 gigawatt hours. As the energy density and safety performance of lithium-ion batteries continue to increase and the cost continues to decrease, lithium batteries become a more effective option for communications, electric power, and data centers. With increasing demand in such fields, lithium batteries are making steady progress towards becoming a new generation of mainstream energy sources. With their small size, lightweight, high density, and their ease of use, lithium batteries are gradually coming to the forefront. There has been an argument that in the industry that the deployment of power systems, with their small size, lightweight, high density, and their ease of use, lithium batteries are gradually coming to the forefront. There's been an argument in the industry that deploying a power system with lithium batteries would significantly increase the construction cost. In recent years, with the rapid development of lithium batteries in consumer business and the popularity of applications in the electric vehicle industry, the cost has significantly reduced. In fact, nearly 70% of that from 5 years ago. Although the price of lithium batteries is still higher than the lead-acid batteries, the advantages of lithium batteries are highly beneficial when considering the technical advantages and the full life cycle value. This becomes more significant as the price difference between the two becomes smaller and smaller in the future. According to market research, the average annual growth rate of lithium batteries in the next 5 years will be 25 to 30%, much higher than that of lead-acid batteries. It is predicted that the lithium batteries will account for around 38% of the market by 2025. An important takeaway here is that the cost of lithium ion is reducing and is expected to see its usage and its market share increase. The primary source of power at the data center is typically the local power grid. In case of a grid power interruption, a backup power source is essential. This is fulfilled through a diesel generator power plant within the data center premises. This also includes on-site storage and handling of fuel, diesel, with underground tanks and a network of pipelines connected to the generator room. In the event of a grid outage, an automatic mechanism will seamlessly switch the facility from grid power to diesel power. An intermediate emergency power backup is provided by a battery-operated UPS system, the IT load. Not all direct backup power is available for compressor or chiller units, so the diesel backup power needs to start and ramp up as fast as possible to take over the entire load. There are several reasons for using battery storage to replace generators. Firstly, using batteries to replace diesel generators can dramatically reduce carbon emissions at data centers. Electricity from inverters can be detonated to generate hydrogen gas, which can drive hydrogen generators as the power source. Or you could directly replace generators with large capacity battery energy storage systems. Secondly, battery technology has matured enough to meet the reliability, quality, and cost requirements. And thirdly, the breakthrough in the management of data center electrical infrastructure enables you to consistently align the amount of backup power available with the amount of power the computing load requires at a given moment. Lithium-ion batteries can be charged and discharged quickly, multiple times, and have high density to store power for use during municipal power troughs. When power usage peaks, the stored power is transmitted to the data center, reducing the impact on the grid. This function will greatly contribute to the energy cost and PUE. It can meet both PUE and TCO requirements of data center users, which is a win-win situation. Important takeaways is that lithium-ion batteries could be used to reduce carbon footprint and improve efficiency of data centers. There are two primary types of valve-regulated lead-acid or VRLA batteries: absorbent glass mat (AGM) and gel cell. AGM batteries feature fiberglass mesh between the battery plates which serves to contain the electrolyte and separate the plates. Gel cells add silica dust to the electrolyte, forming a thick putty-like gel. Both types of VRLA batteries offer advantages and disadvantages compared to flooded vented lead-acid VLA batteries, as well as to each other. A lithium-ion battery, or Li-ion battery, is a type of rechargeable battery. Lithium-ion batteries are commonly used for portable electronics and electric vehicles and are growing in popularity for military and aerospace applications. Chemistry, performance, cost, and safety characteristics vary across types of lithium-ion batteries. Handheld electronics mostly use lithium polymer batteries, a lithium cobalt oxide cathode material and a graphite anode, which together offer high energy density. Lithium iron phosphate, lithium manganese oxide, and lithium nickel manganese cobalt oxide may offer longer lives and may have better rate capability. Such batteries are widely used for electric tools, medical equipment, and other roles. Lithium nickel manganese, or NMC, and its derivatives are widely used for electric vehicles. An important takeaway is that lithium ion is commonplace in use across industries, being used in many different applications. VRLA batteries are commonly used in three-phase sources of uninterruptible power supplies. Due to their weight and dimensions, data centers generally require reinforced bearing structures. The performance characteristics of VRLA batteries are also dependent on the temperature, which increases the load on air conditioning systems. VRLA batteries are not particularly durable and need to be replaced on a regular basis, which also leads to increased operating costs. Operation and maintenance can be challenging using lead-acid batteries. There are often strict operational requirements in various application scenarios, and the temperature must be stable. Only about 600 times of charging and discharging are supported, but the charging and discharging must be performed periodically, and the charging and discharging speed must be moderate. For safety considerations, a separate battery storage room is required. And finally, because of their size, the data center must be designed with floor space and weight bearing in mind. To ensure battery safety, many data centers equip online monitoring devices to ensure the stability of the battery string. While it's worth advocating, the cost is high and often not implemented. An important takeaway here is that from a physical VRLA perspective, the challenges are the floor space, floor bearing, and they are temperature sensitive, not as durable, which can lead to high operating costs. Operation and maintenance can be challenging using lead-acid batteries. There are often strict operational requirements in various application scenarios, and the temperature must be stable. Only about 600 times of charging and discharging are supported, but the charging and discharging must be performed periodically, and the charging and discharging speed must be moderate. For safety considerations, a separate battery storage room is required, and finally, because of their size, the data center must be designed with floor space and weight bearing in mind. To ensure battery safety, many data centers equip online monitoring devices to ensure the stability of battery strings. While it's worth advocating, the cost is high and often not implemented. An important takeaway from the physical VRLA challenges are floor space, floor bearing, they are temperature sensitive, not durable, and can lead to higher operating costs. There is still debate among many organizations favoring more traditional lead-acid battery solutions as the best option for data centers. Huawei believes that the benefits of lithium-ion batteries make them much better suited to the growing market. Lithium-ion technology tends to have a much higher energy density, can achieve an 85% depth of discharge compared to lead-acid's 50%, and is usually 95% or more efficient, meaning almost all of the larger amounts of energy stored in the battery can be harnessed. For a data center, the higher availability of power means that the supply is readily available for longer and can keep up during periods of increased demand. Lithium-ion batteries can be optimized using dedicated software, which can ensure the battery is charged and delivers its output in the most efficient way whilst preserving the unit's lifespan. For a data center, this means the power output can be monitored and the battery can be operated within the most optimal charge range of 30 and 80%. Important takeaways. When considering depth of discharge, lithium-ion is highly efficient and has high availability. Lead-acid batteries are made up of lead, lead sulfate, and sulfuric acid solutions. With the increase of charge and discharge times, the reduction ability of the positive and negative electrode materials becomes worse, and the concentration of sulfuric acid solution changes. Lithium batteries solve this problem very well in material selection. Lithium-ion batteries can achieve up to 6,000 cycles. It's much longer than the 600 cycles of lead-acid batteries. And therefore they can be implemented into data centers for longer and don't require costly replacements as often. Important takeaway here is that the lithium-ion battery has an impressive longevity with over 6,000 recharge cycles, 10 times more than the lead-acid battery, which of course will dramatically affect the total cost of ownership. In recent years, with the rapid development of lithium batteries in consumer electronics and the popularity of applications in the electric vehicle industry, the cost of lithium batteries has reduced by nearly 70% from 5 years ago. In addition, with technological progress and the improvement of national environmental protection requirements, 80% of small and medium-sized lead-acid battery factories in China have closed down. And the price of lead, the essential raw material of lead-acid batteries, has increased. The price difference between the two over time will become smaller and smaller. What's more, a data center should calculate full life cycle costs rather than construction costs. The construction costs account for only 30% of the system life cycle cost, and the remaining 70% is the operation and management cost. In addition, the lithium battery has its own management system after delivery, which does not require manual maintenance. Lead-acid batteries, on the other hand, require an expensive battery management system. Important takeaways. For lithium-ion, the costs are reducing, it's durable, and has a cost-effective battery management. Lithium battery-powered UPS systems can reduce footprint by 50 to 70% compared to lead-acid batteries, supporting scenarios with limited space. When considering lithium and lead-acid batteries' weight-energy density, there is a ratio of approximately 3 to 1. This is similar to the volume-to-energy density with a similar ratio of 3 to 1. Thanks to the higher power density of lithium batteries, the overall solution has a smaller footprint. According to the research results of different scenarios, in the 500 kilowatt 10-minute scenario, the lead-acid area is 2.21 meters squared and the total weight is over 5,000 kilograms. The lithium battery is 1.53 meters squared and the total weight is just over 2,000 kilograms. The space and weight of the lithium batteries are reduced by 31% and 59% respectively. Important takeaways here are that the lithium ions are denser, have smaller footprint, weigh less, and save space and floor load bearing. With the improvement of computing capabilities of IT devices and the upgrading of chip technologies, high density and ultra-high density requirements are consistently emerging. How to support higher load requirements in limited space is an issue that every designer needs to consider. Only a flexible power supply and distribution system can meet the construction and future planning requirements of different customers. Currently, the modular UPS system can be flexibly expanded online. Therefore, the lithium battery design must be scalable. Lithium batteries can intelligently equalize voltage and current, meeting the requirements of hybrid deployments of old and new batteries, making capacity expansion deployment easier and less costly. Important takeaways here are lithium-ion ability to equalize voltage and to use old and new batteries together lends itself to an easier expansion. Now let's look at how to improve the reliability design of the lithium battery system. The first thing to do is to consider the world's leading lithium battery suppliers. Generally, suppliers are classified into soft power evaluation and hard power evaluation. Firstly, for soft power, we're classified by their R&D product design capabilities and technology maturity. For hard power, considerations are based on market share, material processing, production line cleanliness, manufacturing and testing processes, and certificate standards. The major international producers of lithium batteries are concentrated in Asia countries, such as China, Japan, and South Korea. Contemporary Amperex Technology Company Limited, abbreviated as CATL, is a Chinese battery manufacturer and technology company founded in 2011 that specializes in manufacturing of lithium-ion batteries for electric vehicles, energy storage systems, as well as battery management systems. Other manufacturers are Panasonic, Sanyo, Samsung, LG, and BYD. Important takeaway here is that the main producers of Li-ion batteries are China, Japan, and South Korea. Chemistry, performance, cost, and safety characteristics vary across types of lithium-ion batteries. Handheld electronics mostly use lithium polymer batteries, a lithium cobalt oxide cathode material, and a graphite anode, which together offer high energy density. Lithium iron phosphate, lithium manganese oxide, and lithium nickel manganese cobalt oxide may offer longer lives and may have better rate capability. Such batteries are widely used for electric tools, medical equipment, and other roles. NMC and its derivatives are widely used in electric vehicles. Important takeaway here is that the different types of lithium-ion have different characteristics and are applied to different applications. As we talked about before, chemistry, performance, cost, and safety characteristics vary across types of lithium-ion batteries. In terms of molecular structure, both LCO and NCM are layered 2D structures, which are relatively unstable. Although LMO is in a cubic crystal 3D structure, it is relatively dangerous to use because it is prone to thermal runaway in high temperature environments, and oxygen will be generated when thermal runaway occurs. The following data shows that the thermal runaway temperatures of the LMO, LCO, and NCM are between 150 degrees and 180 degrees centigrade respectively, and all of them generate oxygen. The lithium iron phosphate, LFP, on the other hand, shows itself to be more temperature resistant and does not produce oxygen when thermal runaway occurs. The important takeaway here is that LFP is stable during thermal runaway, not producing oxygen, so less chance of a flammable incident. So let's look at the comparison between LFP and LMO in regard to thermal runaway. A typical lithium battery failure occurs when the cell fails. The internal resistance of the cell increases. Internal damage is short-circuited, and overcurrent may cause the cell temperature to rise. At high temperatures, the positive and negative materials of the battery decompose, resulting in thermal runaways causing smoke and fire. Proper management system architecture is the key to prevention. The system must be capable of monitoring cells, batteries, and racks. In addition, protection measures must be taken to cope with abnormalities, and in case of overtemperature or overcurrent of cells, damaged batteries must be isolated in time to prevent fire. The important takeaway here is clear. Appropriate management and containment of lithium-ion batteries maintains a safe and protected environment. The preventive measure is to have a well-structured management system for monitoring. We believe a good surveillance system must have at least 3 levels of protection. First level, the BMU for the battery module. This is for the voltage and temperature detection and battery current balance management. The second level, the BCU, is for the rack, and this manages the BMU and the charge and discharge current detection. The third level, the SBCU, is for the system as a whole and manages the BCU and BMU systems and the communication with the UPS or network management. It also handles the alarm management and report analysis, the state of charge and state of health, the alarm and protection of abnormal work, and the current balance control between cabinets. So to recap, let's look at the important takeaways. The cost of lithium-ion is reducing and expected to see further increased usage and market share. It's been demonstrated that using lithium-ion battery solutions reduce carbon footprint and improve efficiencies of data centers. Lithium-ion is commonplace in its use across industries, being used in many different applications. The physical VRLA challenges are floor space, floor bearing, temperature sensitivity, durability, and O&M challenges. When considering depth of charge, lithium-ion is highly efficient and has high availability. Lithium-ion battery has an impressive longevity with over 6,000 recharge cycles, 10 times more than VRLA, which affects the total cost of ownership. In comparison to VRLA, lithium-ion has a cost-effective battery management solution. Lithium-ion are denser, have smaller footprint, less weight, and save space and floor loading. Lithium-ion's ability to equalize voltage and use old and new batteries together lends itself to an easier expansion. Main producers of lithium-ion batteries are China, Japan, and South Korea. Different types of lithium-ion have different characteristics and are applied to different applications. Lithium-ion LFP is stable during thermal runaway, not producing oxygen, so there's less chance of a flammable incident. Appropriate management and containment of lithium-ion batteries maintains a safe and protected environment. That's the end of our presentation. I hope that you found it informative. If you do require any further information, then you can visit our website www.huawei.com, or by all means you can contact me. I'm Tim Smith on tim.smith1@huawei.com. Thank you very much.